For most of a year, the Eiffel Tower was 4 separate iron arms leaning out over nothing. 57 meters up, they had to meet. If they missed, the whole thing was scrap. They met to within 1 millimeter. And the man this tower is named after did not draw it. That tower has been standing for well over a century, and it hardly moves. In a strong storm, the top shifts about 9 centimeters. That is roughly the width of your hand. But on a hot, still day, with no wind at all, it shifts twice that far. The sun bends the Eiffel Tower further than the wind ever has. And that is the wrong way round, because wind is supposed to be the entire problem with building anything this tall. You have seen this tower 10,000 times. You have almost certainly never seen the drawing it came off. That curve is not decoration. It is a wind calculation, and the sums were finished 4 years before the tower was. Weight is the obvious problem here, and it is the wrong one. The tower is 7,300 tons of iron. That sounds enormous. Now melt all of it, and pour it flat over the square of ground it stands on. It would come up to 6¼ centimeters. Ankle deep. All of that weight goes straight down. It runs down the 4 legs and passes through iron feet. Below that it presses into blocks of stone and concrete, and into the ground. A stone tower can do that. What stopped them was wind. Wind does not push a tower over by being strong. It pushes it over by being high up. Push the side of a tall thing near the ground, and very little happens. Push it near the top, and you are using the whole height as a lever. The taller you build, the longer that lever gets, and the harder the wind twists the base. Engineers have a name for that twist. They call it the wind's moment. The old answer to it was mass. Build the bottom fatter and heavier until it is too heavy to tip. That works, and it has a ceiling built into it. Every extra meter of height is more material, and that material is also up high, and now the wind has more to push against. You are adding to the problem you are trying to solve. Before the Eiffel Tower, nothing anyone had ever built reached 170 meters, and that ceiling had barely moved in nearly 4,000 years. Eiffel's answer was to stop fighting the wind with weight and to fight it with shape. Here is the rule he used. Pick any height on the tower. Take all the wind pushing on everything above that point and add it up into one single push. That push has a direction. Now draw the outside edge of the tower at that height so that it points straight at that push. Do that at every height, and you get a curve. Not a curve that somebody chose. A curve the wind chose. And when the metal lines up with the push like that, something useful happens. The wind stops twisting the tower and starts simply pulling on one side and pressing on the other. The upwind legs get stretched. The downwind legs get squeezed. Engineers call those two things tension and compression. That is all that is left. Force along the iron instead of across it, and iron is very good at being pulled and pushed along its length. Eiffel wrote this down himself in 1885. The outer curve of the tower, he said, reproduces at a determined scale the same curve of the moments produced by the wind. In plain words, the shape you can see is the wind load drawn. That one decision is why the tower looks the way it does up close. In an ordinary tower, the diagonal bars inside the frame are what fight the wind's twist. They are the expensive part, and you need a great many of them. In Eiffel's tower, that twist is already handled by the shape, so those diagonals are not fighting it. This is where the story usually goes wrong. The diagonals are still there, and they are still working hard. They stop the long legs from bending sideways under their own load, and they carry the uneven shoving that a real gust actually delivers. What they do not have to do is fight the wind's leverage. And that is the difference between a tower that is mostly metal and a tower that is mostly holes. 7,000 tons, 300 meters, and you can see straight through it. A tower that is mostly holes still has to press its whole weight into 4 patches of ground. And 2 of those 4 patches sit beside a river. Digging started on the 28th of January, 1887, and finished 5 months later. The 4 legs did not get the same foundation, and almost nobody notices. The east and south legs sit away from the river on firm ground. Each of their 4 main girders rests on its own slab of concrete, 2 meters thick. Straightforward. The west and north legs sit close to the Seine, in wet ground, and solid ground was much further down. So those 2 legs were sunk inside iron boxes. Each box was open at the bottom and filled with compressed air to hold the river water out. Men dug inside it while it sank under its own weight. They are called caissons. These were 15 meters long and 6 meters across, and they went down 22 meters. Each iron foot on top is held down by 2 bolts, 10 centimeters thick and 7.5 meters long. That is a bolt as long as a 2-story house. Ironwork started on the 1st of July. Nothing was drilled or shaped on site. Every piece arrived from the factory already made, and if a piece did not fit, it went back. Every rivet hole had been placed on a drawing to within 1 millimeter. There were 1,700 general drawings and 3,600 detailed drawings. The drawing office was busier than the building site. Then the legs went up, and they went up leaning. Each leg rises inward at 54 degrees, and for the best part of a year, each one is holding itself up over nothing at all. There is no tower yet. There are 4 iron arms reaching out over empty air. About halfway to the first floor, this became frightening enough that the work stopped and timber scaffolding went in underneath. The Paris papers had a good time with it. One ran the headline "Eiffel Suicide." Another said that Gustave Eiffel had gone mad and been shut in an asylum. Which brings us to the moment the whole job turned on. 57 meters up, those 4 separate legs have to meet a ring of horizontal girders. All 4 of them. At the same time. Level with each other. If one leg is a few centimeters out, then the tower above it is wrong all the way to the top. So Eiffel did not plan to get it right. He planned to be wrong, and to be able to correct it. Every iron foot had a hydraulic jack built into it that could push 800 tons. Under each leg, on the scaffold, sat a box of sand with a plug in the bottom. Pull the plug, and the sand runs out, and the leg settles by exactly as much as you let go. And the legs themselves were built standing slightly steeper than they were meant to end up. That was deliberate. It meant every correction went the same direction. You let a leg down. You never had to lift one. They brought the 4 girders into line to within a millimeter of each other. A millimeter, across a base 125 meters wide. That was the end of March, 1888. So the theory was sound, and the work was careful, and the tower stood. That ought to be the end of it. It is not. In 2004, 2 mathematicians did something nobody had bothered to do. They took the real tower, panel by panel, all 29 of them, and measured the actual shape. Then they checked it against Eiffel's own wind rule. The top of the tower matches. The bottom does not. What they found is that the Eiffel Tower is not one curve at all. It is 2 different curves, and they join at about 143 meters, a little way above the 2nd floor. And the lower one, the big famous flare that everybody pictures, does not come out of the wind equation. Their paper says the match down there has to be treated as an accident. It gets worse. 10 of the panels near the top sit at exactly the same angle as each other. Not nearly the same angle. The same angle. That stretch of the most famous curve in engineering is a straight line. Which leaves the uncomfortable question. Did Eiffel work the wind out first, Or did he explain it that way afterwards? The answer is in Eiffel's own paper. He wrote it in 1885, for years before the tower was finished, so the wind work came first. It was not a story told afterwards. What the paper shows is better than that, and stranger. He did not trust his own equation in the place where it mattered most. The wind rule assumes you know how much wind is actually pushing on the tower. But the tower is a lattice. Most of it is holes. Working out how much wind a mesh like that catches is guesswork, and guessing low near the ground is the guess that kills you, because that is where all the leverage ends up. So he refused to guess low. For the top half of the tower, he calculated as though the gaps in the lattice were not there at all. As though the whole thing were a solid wall of iron, catching every bit of the wind that reached it. Down at the base, he assumed the wind struck the legs twice over. Those are not realistic numbers. They are deliberately pessimistic numbers, applied exactly where being wrong would have brought it down. And that is why the lower half leaves the curve. The shape is not the equation. The shape is the equation, plus a man who would not believe his own equation in the one place it counted. So go back to the number this film opened with. In a strong storm, the top of this tower moves about 9 centimeters. That is the entire wind problem on 300 meters of iron, and it is that small because the wind is not twisting anything. It is pulling one side and pressing the other, exactly the way the drawing said it would. And on a still, sunny day the tower moves twice that far. The sun warms one face, that side of the iron grows very slightly longer, and the top leans away from the sun by as much as 18 centimeters. Nothing in the structure resists that, and nothing needs to. It is free to move, so it moves, and no harm is done. The thing that had held every builder under 170 meters now shifts this tower less than an afternoon of sunshine does. None of which impressed anybody at the time. On the 14th of February, 1887, while the foundations were still being dug, the newspaper Le Temps published a protest. It came from a group that called itself the Committee of 300. One member for every meter of the tower. That was the name they chose, and far fewer than 300 people actually signed the letter. It was led by Charles Garnier, who had built the Paris Opera. The writer Guy de Maupassant signed it too. They called the tower useless and monstrous. A gigantic black smokestack. Which brings back the sentence this film opened with. Eiffel did not design the tower. 2 engineers in his company did, Maurice Koechlin and Émile Noguier, in 1884. The company architect, Stephen Sylvester, added the arches at the bottom and the stone facing on the feet. Eiffel bought the rights to their design. He put his own money behind it. And he carried the risk, because the state would only pay 1.5 million francs for a job that cost 6.5. He also took every franc of the ticket money for 20 years. Nearly 2 million people went up it during the exposition alone, and it paid for itself inside the first year. And the permit it was built under ran out in 1909. After that, it was to be taken down. What saved it was not beauty, and it was not the argument about the wind. It was a wire. In 1903, the French army began using the tower as an antenna, first for wireless telegraphy and later for radio. It turned out that the tallest thing anyone had built is an extremely good place to put one. The committee had called it useless. It survived by becoming useful. And the shape they were objecting to is still doing the job it was drawn to do. Every line in that silhouette came off a sheet of paper in 1885. Some of it is the wind equation. The rest is a man who would not trust the wind equation. Both have been standing in the open air ever since. You are not looking at a decoration. You are looking at the wind.